Hi, this is Stephen Brower from Rat Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this video here is meant to do all the leftovers from Irvine Chapter 9. Let's just jump into it. What I do want to point out is that what I'm going to end up doing is that 3 of these files are going to be loaded into Canvas, and those 3 files that are loaded have in it the Chapter 9 commands that we're looking at. The demo files that I'm going to run before them is how we would have coded these things prior to Chapter 9, but I'm not going to load those in because it's really the new commands is what is of more interest. So suppose, and actually let me run this and then we'll take a look at what's going on behind the scenes. Suppose I have an array, and what I want to do is copy the elements to another array. Now what I did for this demo is I showed at the very beginning, before we did the move, what the arrays look like, and then after the move, what they're like. And it really is a copy, but I'm saying move because that's the command we're going to get to. Well, actually, we are using move, so it is a move. But remember, move doesn't change the source. Move only changes the destination. Okay, so for copying, so what we've seen up to this point, in other words, before Chapter 9, the way we would have done it, now in this case here, I'm loading both ESI and EDI with the pointer to each of the arrays. ECX is going to have the length. Inside the loop, I'm taking, so ESI, I'm taking from the source array, loading into EAX, and then I'm taking what's in EAX and I'm loading the destination array. The reason why I can't do ESI to EDI is because we can't do memory to memory. That transfer is not allowed. Then we're going to advance ESI and EDI to the next element for both arrays, and then we'll hit the loop statement, which does the ECX minus minus, and if ECX is greater than 0, it goes to the top of the loop. So prior to Chapter 9, this is well, one of the ways that we would have used for copying from one to another. Let me bring the code in. So this file is up in Canvas. It is the demo MOVSD. And let me just compile it and run it. And helps if my focus is in Visual Studio. Let me compile it and run it just to make sure that we're getting the same results. So we start off initially array 2 is empty, and then the data is being copied over. Okay, fine. And I'm going to, now, that's it. These 5 lines here is the same thing that we did previously. And by the way, 3 of the lines are exactly the same. So the loading of ESI, EDI, and ECX, that was in, if I switch back over here, those 3 lines that exist before the loop where we loaded ESI, EDI, and ECX. So here ESI, EDI, and ECX are loaded. ESI is array 1, the source array. EDI is the destination array. ECX is the length. But what we're doing here is we're using this MOVSD command. And it, well, one thing it's going to rely on is that the direction be set. So CLD means that as it's going to be looping through, it's going to be incrementing ESI and EDI. Now, since this is MOVSD, which is assigned D word, then that means it's going to be advancing ESI and EDI by 4, meaning these statements here that we had previously, that's being done for us automatically. The other thing, if you notice, we're just saying MOVSD. It's taken care of behind the scenes, taking the element from this array, loading it into a register, and then taking that value and loading it into EDI. So this is, with the CLD, it's setting the direction. These move statements here are doing the setup, and then this here, REP, it's going to repeat this statement. Well, how many times is it going to repeat it? Well, based on what ECX is loaded with. And what does it do? Well, that's where it will take the element ESI is pointing to, copy it into the element EDI is pointing to, and then it will automatically increment ESI and EDI. Here's the demo of MOVSD. Okay, for this next demo, suppose we have two arrays of the same size, and we want to compare to see, are the arrays the same? And so what we wanted to do was kind of loop down one element at a time and compare the differences and see, well, if they are the same or not. So let me just run this. This is the let me get my focus here again. This is the pre-Chapter 9 way that we would have done it, but let me just run it first. So here it says the arrays are different because I do have a 5, and here I have a 5, 5. If I put it back to 5 so that the arrays have the same values, it's now coming back and saying the arrays are the same. So prior to Chapter 9, what we would have done is, well, this is looking familiar. It's like Groundhog Day. We're loading ESI with the address to one array, EDI with the address to the other array, ECX with the length of the array, and then here we have a loop. And what it's doing is it's loading from one array into EAX, and then it's comparing from the other array to what's in EAX. We can do a memory to register comparison. So that is what's happening here. We can't compare memory to memory, but we can compare memory to register, so we would load it temporarily into a register. So after this compare is done, now remember, it will compare all the ways in which EAX and what's EDI is pointing to, every way in which they're the same or different. And then here I have, so we saw previously in Chapter 6, JE for the jump equal, JNE is jump not equal. So doing the comparison, if they're not equal, we're going to jump out of this loop and load the diff message and then display the message saying it's different. But what happens is if they are equal, it just goes on to the next statements, which moves ESI and EDI, and then goes back to the top of the loop again. If we get out of this loop, that means we didn't find any differences, and then we can just go and display the message that these two are the same. So prior to Chapter 9, this is how we would have written this comparison. Okay, so this is the demo REPE CMPSD file that's going to be loaded into Canvas. And let me run it twice, first with the arrays being different. And it does see that the arrays are different. Let me make the arrays the same. And hopefully it'll say the arrays are the same. It does. Good. So let's see what this one is doing. Oh, that's a lot shorter. These three statements here, those are the same. The loading of ESI, EDI, and ECX. And so that, remember coming back here, this is the one we did previously. We still had to, before the loop, load ECX, ESI, and EDI. That's the same. CLD, so like we saw in the first demo we saw, we had to set the direction. So CLD will set the direction, meaning we're going to go ascending. And okay, the CMPSD. What CMPSD does is it will compare what the element that ESI points to the element that EDI points to. So it'll do the comparison. As long as those were equal, this will keep going. So repeat while it's equal. So meaning if those two values are equal, it keeps going. If they are equal, it will increment ESI and EDI appropriately, in this case by 4, and it'll decrement ECX because we're looping down. And what happens is as soon as it's not equal, we fall out of that repeat. And so here, the test that we're doing here, J and Z, think of that also as being the same as not being equal. And so if we fall out of here, meaning that the REPE it stopped repeating because they weren't equal. When we come out here, well, that's also not 0, and then in that case it would jump to the different part. But if we get past this, they're the same. CMPSD is the special command we're using. For that, the setup, 3 registers have to be loaded, ECX with the number of elements, ESI for one array, EDI for the other array, and then we have to set our direction. And then the CMPSD, we do need the repeat equal command in order for that to work. And that was different than, and I should have made a little more clearer in this. When we did here the MOVSD and we did repeat, this was REP. So in the prior demo, when we did MOVSD, we only did REP because we were just repeating. But here we're doing repeat equal. Okay, so that's the second demo on comparing 2 arrays. Oops. Now the final demo has to do with 2-dimensional arrays. And what this demo is showing here, it's showing the value that ECX has at certain points throughout this nested loop. So ECX is being loaded with the max rows, which we have 3. And so inside the outer loop, now what I'm doing here is I'm displaying what the row is. So I'm displaying ECX. And if you see, because ECX is descending, 3, 2, 1, it looks like this is row 3, this is row 2, this is row 1. Before going into the inner loop, we're backing up ECX. Here I'm loading ECX with the max columns. And now when I come into the inner loop and they display the column, they're going descending, 5, 4, 3, 2, 1. And as we'll see later with a 2-dimensional array, we prefer the rows to go 0 to 2 and the columns to go 0 to 5. So now let's look at a quote-unquote workaround. Okay, let me run this workaround and then we'll take a look at what's going on behind the scenes. What I did for the displays, since we have both the row and the column available, we can clearly see here's row 0, here's row 1, here's row 2, and we can clearly see column 0, column 1, column 2, column 3, column 4. And that is the way we'd refer to the elements in a 2-dimensional array. So if we wanted, in a nested loop, to refer to the elements by row and column, we can't use ECX. So what I did is, well, I treated it like it was another language, like Java. And so I created 2 variables, current row and current column. And what I did is, before the outer loop, I initialized the current row to 0. And before the inner loop, I initialized the current column to 0, because we always want it to reset back to 0 on the beginning of a row. So inside the inner loop, current row and current column have the coordinates of the element that we're on, so the row and the column. And what I'm doing here, just as a comment, because this will help you for the lab, is I'm showing that we could load EAX with the current row, we could load EBX with the current column, and now if I want to do processing on the row column, EAX has the row, EBX has the column. But what I did in here is I just want to display what the value is, and so I'm displaying first the current row, comma, then I'm displaying the current column. So at the end of inside the inner loop, that's where we increment the current column, and at the end of the outer loop, that's where we increment current row. And so just by using these 2 variables, I'm not dealing with registers and doing pushing and popping. Well, I am. We are using ECX for controlling both loops, and we do have to push ECX and then pop it back. But for the row and the column, I'm not using other registers, I am using memory. And so this is sort of a workaround so that we can generate the rows and the columns in the way that we're used to. So that's kind of the end of the leftovers for Irvine Chapter 9.